Hello everyone. I'm discussing chemical bonding in that molecular orbital theory. Myself B. Vijaya, lecturer in chemistry, Indira Priyadarshini Government Degree College for Women, Nampally. So, molecular orbital theory. What is the molecular orbital theory and what are the salient features of the molecular orbital theory? Let us see now. Molecular orbital theory. So, in the molecular orbital theory, when the two atoms of either different elements or same elements, when they combine with each other, they form as a molecule. Means the completely overlapping of the orbitals will be takes place here. So the atomic orbitals of the bonded atoms combines to form molecular orbitals. So here we can see the picture. In this picture, the two atomic orbitals are approaching with each other and combining with each other, and the two atoms are completely merging together, not just overlapping, not just a partial overlapping, just like in a valency bond theory. But in the molecular orbital theory, they completely turn into one molecule. The two atoms of either same elements or different elements will be turned into one molecule, one entity they are forming. And the nucleus of the two atoms and the electrons of the two atoms are also combined with each other, and these electrons revolve around the two nuclei or more than two nuclei. Means how many number of atoms are combining, that is equivalent to number of molecules it will form. The examples are water molecule. In the water molecule, H2O means two hydrogen atoms and one oxygen atom. Both means three atoms are combining with each other and forming a water molecule. In carbon dioxide, one carbon and two oxygen atoms. So three atoms are combining with each other and forming a carbon dioxide molecule. So like ammonia. In ammonia also one nitrogen, three hydrogens are combining with each other. The atoms of the hydrogens and atom of nitrogen combining with each other and forming a NH3 ammonia molecule. So like this, the molecule will be formed by the atomic orbitals. The combination of the atomic orbitals are called as the molecular orbitals. And the theory, the study of this molecular orbital, how they emerged, how they are forming, this will be explained by the molecular orbital theory. And what are the salient features of the molecular orbital theory? Let us see now. The first one is when the atomic orbitals combine linearly, they form molecular orbitals. So this is also explained by the linear combination of atomic orbital theory also. In linear combination of atomic orbital theory, how the orbitals will be combined with each other, it explains. So that is also called as, that is familiar with us, is Lcao, linear combination of atomic orbital theory. So which explains about the how orbitals, atomic orbitals combine with each other linearly. uh, that is Lcao method, means that is the theory how the orbital combine with each other. So they form the molecular orbitals. Here we can see the two atomic orbitals of hydrogen, we can see here, and the two hydrogens when they combine, the atomic orbitals of the two hydrogens are combining with each other here and forming a hydrogen molecule, H2 molecule. When they combine, the atomic orbitals are combining, we can see here the two positive charges represents the two nuclei of the each hydrogen atom. And whatever the number of electrons are there, the electrons are combining, means both electrons are revolving around the both nuclei. Here each hydrogen is having one electron in each, and this one electron of the hydrogen, means each hydrogen are combining, totally completely combining, and it is a multi-centered nuclei molecule, means the molecule is having multi-nuclei, means more than one nuclei will be there. So each atom is having one nuclei, and 1 electron for the hydrogen, for oxygen 8 electrons, for the carbon 6 electrons, so on. So the atomic orbitals combine linearly and forming a molecular orbitals. And a molecular orbital is a region in a space where the probability of finding electrons is maximum in a molecule. So in atom, there is a specific number of the electrons only. So as I told you just now, hydrogen is having 1 electron, and helium is having the 2 electron, lithium is having a 3 electron, sodium is having 11 electrons, potassium is having a 19 electrons, so on. As per their atomic number is nothing but the proton number, so the same number of electrons will be there. So where the electrons present in the atomic orbitals, right? So but when these atomic orbitals are combining with each other, both the atoms are when they combine, it forms a one big orbital that is called as the molecular orbital. In the molecular orbital, the electrons of the both the atoms will jointly revolve around the two nuclei, means multi-nuclei, whatever the number of atoms are combining, each atom is having one nuclei, right? So if two atoms combines, the two nuclei will be there, and around the two nuclei all the electrons of each atom will be revolved. So the probability of the finding the electrons is maximum in the molecular orbitals than even atomic orbitals also. And the third point, the third salient feature of molecular orbital theory is only those atomic orbitals having similar energy and proper symmetry can combine to form molecular orbitals. Here, the energy of the atomic orbitals plays really very important role. And they must having a almost similar energies or same energy levels. So as we already discussed in the valency bond theory also, to overlap or in order to undergo the hybridization also, they must have a similar energy. So right, they must have a atomic orbitals must have a similar energy, and the proper symmetry also required here. The symmetry of the atomic orbitals are also plays very important role here. And whenever they are having a almost similar energies or same energies, and if they are having proper symmetry, then only they can combine with each other and to form a, means they will form a molecular orbitals. Then the fourth point is molecular orbitals are polycentric. Just now, as I told you just now, these are the polycentric. Polycentric means what? Poly means two. Sorry, not two. Poly means many. Centric means center. Center here is nothing but the nuclei of atoms. So, this molecular orbital, when the two atoms of either same element or different element is combining or merging, the they completely merge it together and forms a molecular orbital. And this molecular orbital is having a two nuclei, means that it depends upon the how many number of atomic orbitals are combining also. So polycentric means as many atomic orbitals are combining, and the atoms are combining, the same number of the nuclei will be present. So it is a polycentric, that is electrons move under the influence of all the nuclei present in the molecular orbital, just we have seen here in this picture. And the shape of the molecular orbitals depends on the shape of combining atomic orbitals. So the atomic orbitals, we already discussed, they must have the same symmetry and same energy levels also. And the shape of the molecular orbitals depends on the shapes of the combining atomic orbitals. Here we have to know the shapes of the atomic orbitals. We have s orbital, p orbital, d orbital, and this s and p d orbitals are having a specific shapes. The specific shapes are nothing but the s orbital is having a spherical shape and p orbitals are having a dumbbell shape, but they are having a different orientations also. We need to consider the orientation even, and the d orbitals are also having a double dumbbell shape. So these are the shape of the molecules, and the shape of the combining atomic orbitals will be affects the shape of the molecular orbitals also. So the molecular orbital shape is depends on the shape of the combining atomic orbitals. The number of molecular orbitals formed is equal to the number of atomic orbitals involved. So this point also we discussed just now. That means how many number of atomic orbitals are combining and the same number of the molecular orbitals will be formed. So let us see now. Here this is one s orbital and this is the another s orbital. This is the atomic orbital of any atom we are taking, means in general form I am taking here, and this is the another s atom, means s orbit, orbit means atom. So this is a shape and means a spherical shape means s orbital, s orbital. Both orbitals, atomic orbitals are combining, means how many orbitals are combining here? Two atomic orbitals are combining, and they are giving a two molecular orbitals. So they are combining with each other. When they combine with each other, they are the two possibilities, because the orbitals are having a wave nature, right? Wave nature they are having. And because of the wave nature, we are representing here with the psi A. So this atom represents a psi B. So in the wave, there is a trough and crust and trough, right? So when these are combined with each other, they form the, means when the combination will be takes place, and sometimes they will be subtract with each other also. So when they combine with each other, they forms the bonding molecular orbital, and when they subtract from each other, they forms the anti-bonding molecular orbital. But bonding molecular orbital is always having a less energy than the anti-bonding molecular orbital. And the shapes of this bonding and anti-bonding molecular orbitals will be as similar as the these atomic orbitals are combining. And how many number of atomic orbitals are there here? 1 and 2. So here this is the one molecular orbital and this is the second molecular orbital. So two atomic orbitals are involving in the bond formation. So that two molecular orbitals are forming. Here, if we see the p orbital, when the p orbital combination is taking place here, the p is having a dumbbell shape and the pz, so it is a horizontal overlapping. And when the horizontal overlapping will be takes place, means two atomic orbitals are involving here, and one is the bonding molecular orbital, anti-bonding molecular orbital is forming. So the bonding molecular orbital is represents with the sigma, and the anti-bonding molecular represents with the sigma star. So this is the combination of sigma bonding molecular orbital is the combination of the this horizontal overlapping or horizontal combination of the dumbbell shaped p orbital. So that represents sigma 2p, and the anti-bonding means when the subtraction takes place between these two atomic orbitals, then it will give a sigma star, and which is having a high energy level actually. and sigma star 2p it will form, it represents. And when the vertical overlapping will be takes place, when the vertical overlapping, if these two lobes of the dumbbell shaped atomic orbitals are combined, which will results the formation of molecular orbital, that is the bonding molecular orbital. And since there is the pi clouds are combining vertically, so the pi bonding will be takes place, bonding molecular orbital will be takes place, and the subtraction of these two atomic orbitals will give the anti-bonding molecular orbital that will be represented with the pi star. And when the linear means not linear exactly, but it is a uh, slant means which is perpendicular to these two orbitals. So in the 2py here we are taking in coordination axis anything here, normally we will represent 2px also, and this is represents with the 2py, and this is represents with the 2pz normally in some books. And here the shape whatever it may be means here this coordination elements whatever it may be. So here the horizontal combination of the p orbitals always gives the this sigma bonds only, and vertical and slant overlapping will gives the pi orbitals. So this is very important point here. Vertical and slant combination will give the pi bonds, and horizontal overlappings are gives the results the sigma bond. Why? Because in the horizontal overlapping only these two lobes are participating, these two lobes are combining, but here the two lobes of the each atom is combining here, each atomic orbital is combining here. So that is the reason we have to remember when the two lobes of the p orbital is involving, then we have to give the pi symbol, means pi orbital. We have to consider it as a pi orbital, and the combination will be the pi sigma, no, sorry, pi bonding molecular orbital, and subtraction will gives the pi star anti-bonding molecular orbital. So here there are the two types of the molecular orbitals will be forming here. One is the bonding molecular orbital, it may be sigma or pi, and the another one is the anti-bonding molecular orbitals, that is a sigma star and pi star. Anti-bonding molecular orbitals are having always higher energy, they represents with the star symbol, and bonding molecular orbitals will represent normally with the sigma or pi symbol only. The next one is the, yeah, I told you here, the bonding molecular orbitals always having a lesser energy than the pure atomic orbitals. So here in the first thing, these are the pure atomic orbitals. The pure atomic orbitals are combining with each other and forming a molecular orbitals here. So these bonding molecular orbitals are having always less energy than the pure atomic orbitals, and anti-bonding molecules are always having a more energy than the pure atomic orbitals. So here the pure atomic orbitals are in between the, means the energy of pure atomic orbitals are in between the bonding molecular orbitals and the anti-bonding molecular orbitals. So we can see here in this picture, these 1s and 2s are the pure atomic orbitals of one atom, and here the 1s and 2s are the pure atomic orbitals of the another atom of the same element or different element, whatever it may be. So these are the pure atomic orbitals. The orange color ones are the pure atomic orbitals, and here this These are the blue color ones are the molecular orbitals, and in this molecular orbitals they represents with the means there are the two types of the molecular orbitals are there. One is the lower energy, one is the bonding molecular orbital. So always the lower energy is the bonding molecular orbital and the higher energy will be the anti-bonding molecular orbital. That is the reason this sigma we have to show molecular orbitals with the sigma and pi, right? So this sigma 1s orbital is having a lesser energy than the 1s orbital, pure atomic orbital of the atom. So this is as per energy. We must not forget this. This is the energy level diagram. So we should not forget this arrow and energy we have to write over here. So if you don't write, uh, the marks will be means decreases. You can lose the marks. And here this two sigma 2s and sigma star 2s. So how we will write the actually how we will write the electronic configuration for any atom. For example, carbon is there, carbon is having a atomic number 6, right? So 1s2 2s2 2p2, that is the electronic configuration of carbon. So similar way means this electronic configuration we are writing for the pure atomic orbitals, right? So here also in the molecular orbitals also we have to follow the same rules like Pauli's exclusion principle, Hund's rule, etc. And we have to fill the electrons here, and this filling the electrons means while filling the electron, the electronic configuration also we have to write. That is a very important part in the molecular orbital theory. So how the electronic configuration in the molecular orbitals should be written is the molecular orbitals are arranged in ascending order of their energies. Ascending order means what? Lower energy level to the higher energy level. So from lower level to higher energy level we have to fill the electrons. And next point is each molecular orbital can accommodate a maximum of two electrons with opposite spins as per the Pauli's exclusion principle. This is also very much similar in the valency bond theory only. As a valency bond theory, how we will fill the electrons, the same manner we have to fill the electrons here. First, we need to fill one electron and then we have to fill the another electron so that the maximum number of the molecular orbital will be a two electrons only. Each orbital will be a two electrons only, and two electrons we have to fill in the lower energy level, then the remaining electrons we have to fill in the higher energy levels. And electrons get paired up when all the degenerate orbitals are partially filled with one electron each. So this is explained by the Hund's rule. According to Hund's rule, we have to fill the one electron in each molecular orbital, and then we need to fill the pair up the electrons. So this is the molecular orbital for the p block elements actually, and this is the atomic number. Z here is nothing but the atomic number is less than or equal to 7. Means when the up to 7, atomic number 7 is nitrogen, right? So up to nitrogen, that means hydrogen, helium, lithium, uh, beryllium, boron, carbon, nitrogen. So for these 7 elements, first 7 elements we have to not for the s block elements like because they did not having a p orbital, right? So for this hydrogen, helium, lithium, beryllium will be exempted. For boron, carbon, nitrogen, for these three elements are molecules, we have to draw the molecular orbital energy level diagram in this way. So here this is the 1s orbital of one atom and this is the 1s orbital of another atom. When these two atomic orbitals will combine with each other, they will form a two molecular orbitals. One is the bonding molecular orbital and another one is the anti-bonding molecular orbitals. So this is the sigma 1s and this is the sigma star 1s. And similar way, this 2s orbital when combined with the 2s orbital. So here the same energy level atomic orbitals are combining. Pure atomic orbitals are combining same energy, right? And they are giving the and the symmetry of this 2s is also same. The 1s is not combining with the 2s orbital here, or 2s is not combining with the 1s orbital here. So 2s is combining with the 2s atomic orbital of another element only. So when they combine with each other, the molecular orbitals, same number of the molecular orbitals formed as we discussed earlier. And so bonding molecular orbital which represents with the sigma uh, 2s orbital, sigma 2s orbital, and anti-bonding molecular orbital, that is the sigma star 2s orbitals. So when these 2p orbitals are combining with the 2p orbitals, again here we need to remember the same energy and same symmetry. So here three types of the, as per their orientation, three types of the p orbitals are there. One is the one orbital, one low means one dumbbell shaped orbital. P orbital is orienting in the x-axis. That means horizontal manner, vertical manner, and slant manner, right? So the horizontal, whichever overlap means whichever the atomic orbital is orienting on the horizontal manner will combine with the other uh, p orbital of the same orientation. That means both the orbitals should um, have the same orientation only in order to merge together, combine together. So, if this is a px orbital and this should be a px orbital, and this should, if this is a 2py orbital and this should be a 2py orbital, if this is a 2pz orbital and this should be a 2pz orbital. So, in that manner, here we can see now when the horizontal overlapping will be takes place, that will give the sigma 2p molecular orbital, and that is lower energy level, that means it is a bonding molecular orbital. When the vertical and slant orbitals overlapping will be takes place, so that will give the pi bonding. So as I told you, the two lobes of each p atomic orbital is combining, means it is involving in the overlapping, so that will give the pi orbital here. So pi 2p pi pi 2p orbital and pi 2p orbital. So in order to avoid the confusion, we can keep here 2px orbital for the horizontal overlapping, and for here 2py orbital, 2pz orbital. So pi 2py, pi 2pz. And these orbitals are having the same energies also. This is the very important thing here. And if atomic number is greater than 7, greater than 7 means what are the elements we have after nitrogen? Oxygen and halogens, and of course noble gas elements also, and that means neon. So for these elements, this part, the lower, the bottom part of this will be alters, means the sigma 2p orbital will become a more stable atomic molecular orbital, and the pi orbitals of this molecule will become a higher energy than the sigma 2p. So only this part will be alters after atomic number 7, and this part is remains as it is only. Always we need to remember is sigma star anti-bonding molecular orbital is having a very high energy. Why? Because what is the reason? Because the reason is the sigma bond is very stable bond. The sigma bond is formed by the mutual sharing of the orbitals or electrons, whatever it may be. So it is a very stronger bond it will form. So the anti-bonding molecular orbitals, it is a very highly energetic one. Always we need to remember the sigma star means molecular orbital theory. This energy level diagram ends with the sigma star only. So this part will be never changes, but this part will be alters after atomic number 7. So below than the atomic number 7 are equivalent to atomic number 7 means up to nitrogen we need to follow this molecular orbital energy level diagram. And here we can see the left side picture represents the s orbital overlapping and which are giving the bonding molecular orbitals and anti-bonding molecular orbitals, how they will give and what are the shapes of overlapping with each other. That's when the combining. So what are the energy levels? All these things we can see here. So these are the 1s orbitals are overlapping, combining with each other, and same number of the molecular orbitals will be forming as per the energy level in the ascending order. And when the 2px orbital means which is orienting in the horizontal manner. So these two lobes only, the atomic orbitals of these two lobes only, two lobes of the 2px are combining and forming a bonding molecular orbital. That is a stable one, and sigma 2px it is forming. And in the anti-bonding, in the pi orbital, the lobes, the similar lobes are forming here to py when the combination is taking place. So pi bonding molecular orbital will be formed of the 2py orbital combination. And when the 2pz will be formed means it is a slant overlapping will be formed. That is also the pi 2pz it will gives. So here this is 2pz combination is this one, 2pz combination it will give, and this is anti-bonding. Both are having a same energy level, 2py overlapping and 2pz overlapping are both are having the same energy level, but bonding molecular orbital is having a less energy than the anti-bonding molecular orbital. And the next one is 2px orbital. When combined with the another 2px orbital, anti-bonding molecular orbital will be formed. So these are about the molecular orbitals combination. So here how many pure p atomic orbitals are there? 3 p orbitals are there, and here also 3 p orbitals are there. 3 plus 3, how many? 6 pure atomic orbitals are combining. And then how many molecular orbitals are forming here? 3 bonding molecular orbitals and 3 anti-bonding molecular orbitals. Among them, which is the sigma, means this is atomic number greater than 7. So this molecular orbital energy level diagram is used for the molecular orbital means atomic number greater than 7. That means more than 7 means it is after nitrogen atom. So means for oxygen and halogens we will use this one. The next very important part of this molecular orbital theory, which will gives the information of the bond order also. So what is the bond order? Bond order is nothing but which will gives means by this molecular orbital theory we can easily predict, we can easily elucidate the number of bonds between the combining atoms. So here what is the bond order is nothing but it is one half of the difference between bonding electrons and anti-bonding electrons. That means bonding electrons minus anti-bonding electrons. Electrons present in the bonding molecular orbitals minus the number of electrons present in the anti-bonding electrons divided by 2 will gives the bond order. So that will give the number of bonds. That will give the number of bonds, and the bond order will be more. The number of this bond order is more, so this will be the greater strength it is having. So bond order is always inversely proportional to bond length. If bond length will be increases, the bond order will be decreases. Okay, or otherwise if the bond order is more, that means the bond strength will be more. Bond strength will be when it will be more, so whenever it will be short bond length it is having, then only it will get the higher bond strength actually. So which is bond order is always inversely proportional to the bond length, and bond order is inversely less energy it is having. Bond order is inversely proportional to the energy also. Why? Because which is having a high strength and low energy. So whenever the greater bond order is there, it is having requires a higher greater bond strength and less energy, because it gets a stable one. It gets a stability. Right? So that is the reason bond order is always inversely proportional to the bond length. And the next very important part of this molecular orbital theory is which will explains about the magnetic behavior of the molecules also. So here the magnetic behavior, the two types of the magnetic behaviors we have, that is the diamagnetism and paramagnetism. What is the diamagnetic substances? The substances which show the molecules which exhibit the diamagnetic property, that is called as the diamagnetic substances, and which are basically unaffected by the external magnetic field. What that means is, whenever if we keep this molecule, the diamagnetic molecule, in the external magnetic field, so the external magnetic field will be repulse this compound. What is the reason? Because so for the magnetic behavior, the electrons are the responsible for this one magnetic behavior. So whenever the molecule is having a unpaired electrons, then this unpaired electrons are acts as the magnetic poles. But in the diamagnetic substances, the unpaired electrons are not there, means all are the paired electrons only. So if all the electrons are paired with each other, there is no motion at all. Motion means here each electron is having the two types of the motions. One is the orbital motion and another one is the spin motion. So this spin motion and orbital motion will give the some specific property called as the magnetic behavior for an electron. That is the reason each electron is acts as the magnetic pole. But whenever they paired with each other, the spin will be given to the each electron is half, right? So this one electron is up-headed arrow and another electron is on the down-headed arrow. So the spin of this electron will be a plus half and the spin of this electron will be a minus half. So plus half minus half, which will give the net spin motion is 0. So there is no spin motion and there is no, since they are paired electrons, there are no orbital motion also. So that is the reason the diamagnetic substances will be unaffected by or repulsed by the external magnetic field. Whereas if we see the paramagnetic substances are affected by or attracted by a external magnetic field when they kept. So they contain at least one unpaired electron, and because of presence of this unpaired electron, they are having a spin motion as well as the orbital motion also. So because of these two motions, it gets the magnetic behavior. So here the two types of the diatomic molecules, means in the degree level we are discussing about only diatomic molecules. And in the diatomic molecules, when the two atom, diatomic means what, two atoms are combining with each other in order to form a molecule, those are called as the diatomic molecules. And here homonuclear means what, the atoms of the same element are combining with each other. These are called as the homonuclear diatomic molecules. And here the first example I am taking, the example 1, that is hydrogen molecule. So how this hydrogen molecule will be formed? The atomic number in this molecular orbital theory, we have to know, means from here onwards it is very important to know actually. And the atomic number of hydrogen atom, that is 1. So the electronic configuration of hydrogen atom is 1 and total number of electrons in H2 molecules, means here atomic number of H2 molecule they have given, means this is the combination of two hydrogen atoms, right? This is the atomic orbital of one hydrogen and this is the atomic orbital of the two hydrogen atoms. And because of this reason, this atom is having a one electron, one atomic number is 1, and for this hydrogen also atomic number 1. This is having electronic configuration 1s1 and this is also having a 1s1. So the total number of electrons in the H2 molecule, how many electrons will be there? Here one electron, here one electron, totally 2 electrons are there. So this is the molecular orbital energy level diagram. So one electron we are keeping here for in the pure atomic orbital of the hydrogen, and this is also pure atomic orbital of another hydrogen here. When they merge it together, they disappear and forms the molecular orbitals. One is the sigma bonding molecular orbital and another one is the anti-bonding molecular orbital, that is the sigma star anti-bonding molecular orbital. How they will form? We can see here in the bonding molecular orbitals there are the two electrons are there and there are no electrons are present in the anti-bonding molecular orbitals. Now please say is there any unpaired electrons are there in the molecular orbitals? We should not consider these electrons now because these atomic orbitals are combining with each other and they are disappears, and the formation of this molecular orbitals only takes place now. So we have to see the number of electrons here only, the molecular orbitals only. So is there any molecular orbitals are there in the this unpaired electrons are there in the molecular orbitals here? No. So here sigma, this bonding molecular orbital is having a two electrons. So these are the paired electrons, and because of this reason this is a diamagnetic substance. That means when it kept under the external magnetic field, it will be having no effect by the external magnetic field. And what is the bond order? The bond order is nothing but what? The number of electrons present in the bonding molecular orbitals minus the number of electrons present in the anti-bonding molecular orbitals, that is divided by 2. So here two electrons are there in the bonding molecular orbitals and 0 electrons. There are no electrons present in the anti-bonding electrons. So 2 minus 0 will be 2 only. 2 divided by 2 is 1. That means bond order is 1. And this is a very stable molecule and which will forms a hydrogen single bond hydrogen, right? So single means this bond order is nothing but the number of bonds it is forming. So hydrogen, single bond hydrogen it will give. And this is the helium molecule, and the helium molecule is having a atomic number is 2, and electronic configuration is 1s2. And how many total number of electrons present in the helium molecule? 4 electrons present. 2 plus 2 electrons, 4 total. Here one helium atom is having 2 electrons, and here 2 electrons, total 4 electrons are there. And these 4 electrons they distribute in the bonding and anti-bonding molecular orbitals in a, as shown here. So this one electron will enter here, and one electron of this will enter here, and one electron of this enter here, and one electron of this enter into the sigma star anti-bonding molecular orbital. And what is the electronic configuration? Sigma bonding molecular orbital is having a 1s2 electronic configuration. Sigma star is also having a 2 electrons. So bonding molecular orbital is having 2 electrons. Anti-bonding molecular orbital is also having a 2 electrons. So which is the diamagnetic property? Because since they are not having any unpaired electrons in the bonding as well as the non-bonding electrons, means anti-bonding molecular orbitals. So 2 minus 2 gives us 0 divided by 2, that is a 0. That means the bond order, there is no bond takes place between the two helium atoms. The two helium atoms never combine with each other uh, as per the molecular orbital theory. So this is the unknown molecule. Unknown molecule, there is no bonding takes place between the helium and helium.